Hi everyone, welcome to this quiz on motion chapter. So we are going to be looking at lots of interesting and important questions on motion. So welcome to this quiz, and I'm going to be showing you the tips and tricks on how to solve the questions. So be sure to watch the entire quiz. So I hope all of you are excited. Good evening, welcome everyone to this quiz. Hi, good evening. Hi Aryan Gupta. Hi Kapil. Hi Srinivas. Hi Yash Gaming. Hi Yogesh Trivedi. So I see a lot of folks are here. Welcome everyone. Sorry if I can't take everyone's name. So welcome to this quiz on the motion topic, and we are going to look at a lot of interesting questions. So be sure to watch the entire quiz and go hit the like button right now and share this quiz with your friends. And guys, we have this website manochaacademy.com. So do check it out. We have the physics CBSE class 10 full course, for CBSE class 9 and for ICSE class 9. And soon we'll be putting the courses for chemistry and mathematics also. So do be sure to check out our website manochaacademy.com for these courses. I'll put the links below. And we've got big discounts going on these courses. So be sure to avail them. And these courses have interactive videos, quizzes, questions for you to practice. So I'm sure you'll find them really useful. So I hope all of you are excited for this quiz. So let's dive right into it. Guys, here's our first question. The motion of a simple pendulum is an example of A. Linear motion, B. Vibratory motion, C. Oscillatory motion, or D. Rotational motion. So guys, what do you think? Do let me know your answer in the chat here. Okay, good. I'm seeing a lot of answers here. Very good. So basically we are trying to classify the type of motion for a simple pendulum. And if you think about it, you know that a simple pendulum, it moves to and fro like a swing, right? So you guys know that the pendulum moves like a swing. So it's going to go from this position, then it's going to go down here, and then to this extreme position. So it's going to go this way and then back, right? So simple pendulum is like a swing. And guys, as you know, we say a swing oscillates about its center position, right? Or a pendulum, we say it oscillates about its mean position. So excellent. I see most of you got the correct answer. The answer is oscillatory motion. Okay. And don't confuse it with vibratory motion, because vibratory motion, a good example is when you pluck the strings of a guitar. So strings of a guitar, we say they vibrate when you pluck them. So this is not an example of vibratory motion, it's an example of oscillatory motion. And the first option, linear motion, means in a straight line, and rotational motion means something like a fan rotates, right? So the correct answer here is simple pendulum shows oscillatory motion. Excellent. I see a lot of you have got the right answer. Superb. Now guys, let's take a look at the next question. The wheel of a moving car is an example of linear motion, translatory motion, or is it rotational motion, or mixed motion? So guys, what do you think? Okay, so I'm seeing a lot of answers here. Excellent. I see a lot of people are participating in the answers. So guys, please think of the answer and think of all the options that you see here, right? So when this wheel is rotating, okay, so imagine this car is moving this way, right? So you can imagine this wheel is going to be moving, right? Okay, so can we say when the wheel moves, the wheel is rotating? So definitely the wheel is, we all know that the wheel of a car rotates. But you know that a car also moves ahead, right? So it can either move in a straight line or it can move in a curved line. Okay, so definitely it's rotating and moving. Okay, so rotational motion cannot be the only answer because the wheel is also moving ahead. Okay, so and what does this word linear and translatory mean? Linear means it moves in a straight line. But translatory motion means that it could be moving in a straight line. So it can be linear or curvilinear, which means it might be moving in a curved path, right? So that is translatory motion. So clearly the wheel can be having translatory motion and rotational motion. So therefore it is two types of motion, right? It can be rotating and it can be in a translatory motion, right? Both of them, because the car is moving ahead. So the correct answer here, superb, a lot of you have got it. It's mixed motion is the right answer here. So mixed motion, why? Because it is both rotational, it's in rotational motion and in translatory motion. Okay, so therefore we say since it has two types of motion, it's not just one type, so we call it mixed motion. So the correct answer is D. Very good, excellent. Now let's go on to the next question. What instrument is used to measure the distance traveled by a vehicle? Okay, so imagine guys, you're going in a bus or in a car. How do you measure the distance that you've traveled? So how do you practically measure it? So do you use a speedometer, a tachometer, a odometer, or a fuel indicator? So what do you guys think here? So I see some people are saying C, A. What do you think is going to be the correct answer here? Some people are saying speedometer, odometer, right? What do you think is the right answer here? So very good. Most of you have got the correct answer. The right answer is odometer, because the odometer gives the distance traveled. And as you can see in this picture, the odometer is over here. So this is our odometer. Let me mark it with the green color here. So that's our odometer. We call this the odometer reading. The speedometer is over here. So this is our speedometer, right? The speedometer is showing the speed of the vehicle, but odometer gives the distance traveled. And here in this car, you can see the reading is 10180 kilometers right now. So suppose that's your initial reading, okay? And let's say when you reach your destination, the final reading is 10190 kilometers. So guys, what is the distance you've traveled? So this is our initial odometer reading and this is the final one. So how much distance do you think the car has traveled based on this numbers? What do you think, guys? So what do you think? Very good. The correct answer is you just have to subtract the two readings, right? So we just do this reading, the final minus the initial reading, and there you can see it's 10 kilometers. So you just subtract the odometer readings and that's going to give us the distance traveled by the vehicle. Okay, some of you are asking what is tachometer? Tachometer measures the rotational speed. So you can look up that on the net. And fuel indicator is simple. It measures the amount of fuel in the car. And speedometer measures the speed. So the correct answer for the distance traveled, this gets asked a lot of time in your tests. What instrument do you practically use? You use the odometer. That's the correct answer here. Excellent. Now let's take a look at our next question, guys. Are you ready for it? Which one of the following is not a vector quantity? A, displacement, B, speed, C, velocity, or D, acceleration? So guys, what is the answer here? Which one of the following is not a vector quantity? Okay, good. I'm seeing a lot of you are giving the correct answer. Excellent. Okay, I see a lot of speed here. I see some accelerations also. That's the main answers I'm seeing here. So most of the answers that I see in the chat is either speed or acceleration, right? So which one do you guys think is the right one here? So first, let's understand what is a vector quantity. So vector quantity has both magnitude and direction, right? So quantity that has magnitude means has some value and it has a direction. So for example, if we say 10 kilometers northeast, so 10 kilometers is the magnitude and the direction is northeast. So that is the meaning of vector quantity. But here we are asking not a vector quantity. So what is the opposite of the vector, not a vector quantity? It is a scalar quantity. And scalar, as you know, it has only magnitude. Means it only has a value. There's no direction. So it does not have any direction. And guys, let's go over these options here. Displacement by physics definition, it is a vector quantity. So it can't be the first option because that has a direction. The next one, speed. Okay, so speed is a scalar quantity. We only say 10 meters per second or 20 meters per second. So it has only magnitude, no direction. So that's our right answer. Velocity, we say, is speed with direction. So guys, remember this important concept. Velocity is known as speed with direction because it is a vector quantity. It has both magnitude and direction. Like 10 meters per second north. Okay, so 10 meters per second is the magnitude of the velocity and north is the direction. And acceleration, which is the rate of change of velocity, is also a vector quantity. It has direction. Okay, so some of you are asking, what is velocity? Velocity is basically speed with direction. So an example of speed, if you take an example of speed, is a speed of 10 meters per second. So guys, see, it has only a value, but velocity, we say, let's say a car is moving 10 meters per second north. So we are saying, we are giving its direction also. Many times in the sums, the direction is not given. That doesn't mean there's no direction. They've ignored it. But the velocity has to have both magnitude and direction because it's a vector quantity. So the correct answer for this is, which one is not a vector means which one is a scalar. And our right answer is B, speed. Superb. So we'll be coming to acceleration. I see some of you asking, what is acceleration? We are coming to a question on that. So don't worry, it's coming up. Let's take a look at our next interesting question. A man walks around the perimeter of a triangular field as shown below. What is the total distance traveled by him here? Okay guys, take a look at this question. So man walks around the perimeter of this triangular field. So let's say the man is at the point A. Okay, so let's say he's at his starting position. So I'm going to draw the man here. He's at A. Okay, and so let's say the man walks along the perimeter, which means he walks this thing AB, BC and CA, right? You know, that's the perimeter of the triangle. Okay, so now you need to calculate what is the total distance traveled by him. Okay, good. I'm seeing a lot of answers here. So excellent. A lot of you are trying the sum. That's great. So please take a look. What will be the total perimeter traveled by this man? So what do you guys think is the answer? I'm seeing a lot of 50s, 70s, 120s. Okay, nobody's saying 0. Okay, because he's moving. So right, he's traveling some distance. It can't be 0. Okay, so I see a lot of good answers here. But a lot of different answers, right? Some of you are saying 50, 70, 120, which is the right answer? Let's see how to analyze this question, okay? So in physics, be very clear about the concepts, apply them, okay? And then you'll find it really easy. So first, let's understand we are looking for the total distance, right? And total distance means the total length of the path traveled. So total length of the path traveled by the person, right? And what is the total length of the path traveled? It's going to be this thing AB plus BC, right, plus CA. Okay, so he's traveling that entire path. So our total length of the path is going to be, or the total distance. So total distance is basically going to be AB plus BC plus CA. Clear? So that's simple. Okay, now AB we know it's 30 meters, BC is 40 meters. And now the interesting thing is, what is CA? CA is not given in this question, but how do we calculate that? Okay, so good. I see a lot of right answers out here now because can you see, we've been given that this is a right angle triangle. It's not any simple triangle. It's a right angle triangle. So what can we apply here? That's right, Pythagoras theorem. Okay, so we can calculate the hypotenuse of this right angle triangle. And you know the hypotenuse is going to be square root of these two sides, right? 30 square plus 40 square. C is the hypotenuse here. It's opposite to the 90-degree angle. And if you work that out, it's going to be 50 meters. Okay, so let's substitute that here. So plus 50 meters here, right? And now if you add up all those numbers, what do we get? We get 120 meters. So the total distance, excellent. But guys, don't write 120. Remember, I told you in the last class also, units are very important. So be sure to mention the unit meters. So the correct answer here is 120 meters. Don't forget to write down the units. Excellent. So the correct answer here is What is our right answer? D, 120 meters for this question. Okay, clear? So we applied the concept of total distance, which is the total length of the path traveled, and then we calculated it using the Pythagoras theorem. Excellent. Now let's go on to our next question. A man walks around, so it's the same thing, the perimeter of a triangular field as shown below. What is the total displacement of the man? So it's similar to this previous question, but now we are interested in not the total distance, but the total displacement of the person. Okay, so guys, what do you think is going to be the answer? So when he walks around the perimeter, as we discussed, he's going to walk AB, BC, the perimeter of the triangle, CA. Okay, so look here, he's going to walk AB, BC, and he comes back to A. So guys, what is going to be the right answer here? So I see some zeros, some 50s. Okay, read the question carefully. Don't jump to the answer, guys. Take a look. So what is the definition of displacement? Remember, the shortest distance, right? So the shortest distance from initial to final position, right? From initial to the final position, right, guys? And what is his initial position? So you can see here we've marked, this is our initial position, and the man goes around like this. So, and then he comes back to A. So the man is back here at A, and so this is also his final position, right? So the initial and final position is the point A. Okay, I've just drawn the man twice, but he comes back to the same position, A here. Okay, and so since he's come back to the same position, excellent, a lot of you guys got the correct answer. It is going to be, since he's back to the same position, the distance is 0, right? Because the initial and final position are the same here. So the right answer is going to be, the correct answer is 0 meters. Don't think it's because it's displacement, let's quickly apply Pythagoras and find the length of CA and it's 50 meters. No, go by the definition, find out. So for displacement, always look at and ask yourself, what is the initial position? What is the final position? And then base your answer on that. Okay, guys? So excellent. I see a lot of 0 meters. Superb. That's the right answer. Now, guys, are you ready for the next question? Here it is. Speedometer of a vehicle measures A, the average velocity, B, average speed, C, instantaneous speed, or D, is it acceleration? So guys, what do you think is the answer here? Okay, so remember, as we discussed, our speedometer is here. So this is our speedometer. Okay, and it's right here. Okay, and remember we had discussed the odometer was here, right? So this was our odometer, which measured the distance traveled. But this question is asking speedometer. Speedometer of a vehicle measures what? Okay, so I see a lot of B's and C's. Some people are saying D also, acceleration, right? So a lot of different answers here. So guys, what do you think is the right answer for this? You've all seen a speedometer, I'm sure, right? Either in a bike, a motorbike, a car, a bus, right? So, and next time I want you to take a look at these things in your everyday life, right? So next time when you're traveling, try to see the speedometer of a vehicle, try to analyze what's going on so that you get a feel of physics, okay? It's not just what's written in your textbook, right? So please connect the real world with what you're reading. Okay, so good. I'm seeing a lot of tries here. Some of you are saying B, C, D, okay? Nobody's saying A. That's fine. Let's take a look. What will this be? Okay, by the name you can guess speedometer, so probably the answer should be B or C, right? Because the name is speedometer. So it should be measuring either the average speed or the instantaneous speed, okay? It can't be measuring velocity, it's because it's not telling us anything about direction, right? It's just giving us the value. So it can't be the first one, and it's not acceleration, because acceleration, we are going to come to that, it's the rate of change of velocity, or if we roughly just want the value, it's the rate of increase of speed, right? So which one is the right answer? Is it the average speed or the instantaneous speed? Okay, so let's clearly understand this concept. Average speed, remember what is the formula? So if some of you may know it, or if you don't know, the formula is very simple. It's total distance, right, divided by the total time. So total distance by the total time. So when a car travels, let's say a distance of 40 kilometers in 1 hour, so the average speed is going to be 40 divided by 1 hour, right? So you're measuring the total distance, which you can calculate from the odometer, and measuring the time, which you can calculate using a clock, right? So average speed is giving you a average of the speed, because we know that when a car is moving or a vehicle moves, right, the speed keeps on changing, because it may be stopping sometimes, it may be moving very fast when the road is clear, or in traffic the speed may slow down. So you can imagine that this speedometer or the speed of the car keeps changing, and that's why we have this term of average speed, right? But instantaneous speed, what does that mean? This term means instantaneous speed. It's a very important term. So it simply means the speed at that instant. So speed at a given instant. Okay, so given instant means, let's imagine you're traveling in this car and this is your dashboard here. So if I ask you what is the speed right now at this instant, okay, that is called the instantaneous speed. Okay, so if the car is stopped, the instantaneous speed will be 0. But let's say the car is going at 20 kilometers per hour, then the speedometer will be showing this reading here. Can you see? So the speedometer will point to 20, but let's say the driver goes really fast now, and now the speedometer will be at 60. Okay, so the speedometer, keeps changing as the car is moving, and it's trying to give you the speed at that instant. So excellent, a lot of you've got the right answer. It is instantaneous speed. Speedometer doesn't tell us the average speed. That we need to calculate ourselves, because it's telling the driver at that instant, right? So imagine you're the driver, you can understand that, are you traveling really fast right now or really slow, right? Because you shouldn't be going above the speed limit, otherwise the police can catch you. So police is not going to look at your average speed, they're going to look at your speed at that instant, and that's what the speedometer gives. Excellent. Now let's move on to the next question. A car travels 18 kilometers in 30 minutes. Now we need to find so this question is asking find the average speed. Previously we looked at the instant speed. So here we need to find instantaneous speed, sorry. And so here we need to find the average speed of the car in SI units. Okay guys, so get your pen and paper ready and try to solve this sum, or maybe you can solve it, you can try mentally also, right? To do some mental calculations, or use a pen and paper. So try to solve this question. What is the average speed of the car in SI units? Okay, so all of you please try this question. Great, I'm seeing a lot of answers here. So please try. Okay, very good. So I'm seeing a lot of different answers here. I want all of you to take some time and do the calculations here, because what is the question asking? A car travels 18 kilometers in 30 minutes. So like we discussed here, the formula of average speed is, so what is the formula of average speed? Total distance by total time, right? So let's say this car has traveled 18 kilometers. So this car is moving, and so let's say the total distance traveled here by the car is 18 kilometers, and it took 30 minutes, right? And the car took 30 minutes to travel this distance. Now we need to find the average speed of the car. Okay, so let's go ahead and use our numbers here. So it's going to be 18 kilometers, which is the total distance here, and the total time 30 minutes. If you want it in hours, 30 minutes is how many hours? It's half an hour, right? So it's half of an hour. So if you do the maths here, what do you get? The average speed is going to turn out to be 36 kilometers per hour, right? So do you guys agree? So the average speed is going to be 36 kilometers per hour. But is that the correct answer or not? What do you guys think here? So I see a lot of people have written 36 kilometers per hour. So good, you guys are trying, excellent. But note this question carefully. It's saying you want the speed of the car, not just the average speed, we want it in SI units. So if it didn't say SI units, then this is perfectly a right answer. 36 kilometers per hour is a great answer, but we want it in SI units. Okay, So what do we need to do? Remember, SI units, the average speed, the unit is, so the unit is going to be meter per second, right? That is the SI unit of average speed, because distance, you know, is measured in meters in SI units and time is measured in seconds. Okay, so we need to convert this into SI units. Now, how do we do that? So let's convert 18 kilometers. So let's try it here. So 18 kilometers is going to be, so let me use the green color here, and 18 kilometers is going to be 18,000 meters, right? And we've been given 30 minutes. Okay, so 30 minutes is how many? 30 into 60 seconds, right? So now you can sit and do the math here. And how much do you get? So good, I'm seeing a lot of correct answers here. Very good. So it's going to turn out to be 10 meters per second, right guys? So if you work out, if you do the division and maths, it's going to be 10 meters per second. But let me teach you a quick trick to do this much faster, right? So previously what had we got? We had got 36 kilometers per hour. Now you can quickly convert that into meter per second. How do you do that? You just need to multiply this number by 5 by 18. Okay, so guys, to convert kilometers per hour to meter per second, remember you need to multiply by 5 by 18. So you need to multiply the number by 5 by 18. So when you're doing this conversion, or maybe I should write it here. So when doing the conversion, we need to multiply by 5 by 18. So that's the fast trick. And so if you multiply it, so you're going to get the same answer, 10 meters per second here. Because you can see 36 by 18 is 2 and 5 2s are 10. So 10 meters per second is the answer. And that's the quick way of doing it. And similarly, you can go from meter per second to kilometer per hour really quickly by multiplying by 18 by 5. Okay. So guys, remember this important trick to quickly calculate so that you don't have to work with these big numbers, right? You don't have to sit and do 18,000 meters and 30 into 60 seconds. Okay. So very good. A lot of you had got the correct answer, 36 kilometers per hour, but note the question, it asked it in SI unit. And SI unit, guys, you know, is meter per second for speed and for velocity. So very good. That's the right answer here. Now let's take a look at the next question. A motorbike is moving at a velocity of 5 meters per second. It accelerates at a uniform rate to a velocity of 15 meters per second. Find the average velocity of the motorbike. Okay guys, so please try this question. Okay, good. I'm seeing a lot of answers. So what is the formula for average velocity? So average velocity, just like average speed, has this formula. Average speed was total distance by total time. So this is going to be total displacement by total time. Okay, so this is the basic formula for average velocity. But one important thing here is we've not been given any displacement and we've not been given any time. Okay, so this formula doesn't help us much, right? So this formula, as you can see, won't help us here. So there's another important formula which is given in your books, that average velocity if the car is accelerating, right? Or it's in retardation, right? So if the acceleration means if it's increasing its speed or increasing its velocity at a uniform rate, or let's say it's decreasing its velocity at a uniform rate, then we can use the formula. It is going to be the average of the initial and final velocity. Okay, so this we can write it as, it is, so u is the initial velocity, so initial velocity plus final velocity by 2. So it's an average of the initial and final velocity, so we can use that. And now if you work out the numbers, it's pretty simple, right? So the initial velocity is given 5 meters per second and the bike is accelerating at a uniform rate, so we can apply this formula. So this formula you can apply only under this condition, but this is the general formula which you can apply without any condition, right? You can always use the general formula, but note, to use this special formula, that condition needs to be satisfied, and it's satisfied here. So we can use it 5 plus 15 by 2. So it's going to be 20 by 2, 10 meter per second, right? So guys, did you get the right answer here? So excellent. I see a lot of you have got C. C is the right answer, 10 meters per second. Superb. Okay. So please take a look here. For average velocity, use this special formula. So don't forget this. Sometimes we tend to forget this formula, u plus v by 2. That is the important one here. Very good. All right, are you ready for the next question? A car is accelerating at a uniform rate of 5 meters per second square. So is the car in uniform motion, non-uniform motion, uniform circular motion, or none of these? Okay, so a lot of you asked me on the chat that what does acceleration mean? Let me explain it to you in brief. Okay, and you can also check out our videos and our courses on manochaacademy.com to watch more detailed lessons, but I'll try to explain it to you in brief here, and you can check out the more detailed lessons in our courses. Okay, so it is accelerating at a uniform rate. So acceleration means rate of change of velocity, right? Rate of change of velocity. So simply speaking, you know that when a car accelerates, it's basically increasing its velocity, right? Or when it is in deceleration or retardation, it's decreasing its velocity. So car is accelerating at a uniform rate means, let's imagine, so let's understand this with an example. Let's say the car was initially at rest. So it had a velocity of 0 meter per second, right? This is our velocity. And let's put time out here. Okay, so the time is 0. Now let's try to understand what will be the speed of the car after 1 second, and after 2 seconds, and after 3 seconds, and so on. Okay, so the car is accelerating at a uniform rate of 5 meters per second square. That basically means the car's velocity is increasing by 5 meters per second every second. So that's why the unit, guys, are you following me? That's why the unit is 5 meters per second square. So this is the initial velocity of the car here, 0 meter per second. So after 1 second, it's going to be 5 meter per second, right? Then after, because it's increased by 5 meter per second every second, then what is it going to be at 2 seconds? It's going to be 5 plus 5, so 10 meter per second. And then the car is moving this way, right? And then it's going to be 15 meter per second. So guys, can you see that every 1 second, right? When it's going from t0 to 1, 1 to 2, can you see every 1 second? So every second here, the car's velocity is increasing by 5 meters per second. So that's why we say the acceleration is 5 meter per second square. And acceleration has this formula which you can note. Acceleration is the rate of change of velocity. So the final velocity minus the initial velocity by time. So if you apply that, you can see that also here. It's going to be, the acceleration in this case is 5 meter per second square. Okay, so now you have a brief idea of the acceleration, but you can check out our more detailed courses also on our website. So now let's take a look at this question. So is the car in uniform motion, non-uniform motion, uniform circular motion, or none of these? Okay, if this car is accelerating. So very good, I see a lot of answers here. And so how can we eliminate the answers? So uniform motion means the car is moving at a so the strict definition is it's moving at a constant velocity, which means it's moving at a constant speed and in a straight line. But now we can see that this car is not moving in a constant speed. The speed of the car is increasing. So the first option is not correct, because uniform motion means speed is constant and direction is constant. Okay, it can't be uniform circular motion because there's no mention of the car moving in a circle. So the correct answer is non-uniform motion, right? So very good. The correct answer is B here, because the speed of the car is changing. So it's in non-uniform motion, right? It's not traveling. Uniform motion means it travels equal distance in equal intervals of time, which basically means it's at a constant speed. But since the speed is increasing, it can't be traveling equal distances in equal intervals of time. So it's traveling unequal distances in equal intervals of time. And that is why the correct answer for this accelerating car is non-uniform motion. Great. So are you ready for our next question? So this is about a train. A train is moving with a speed of 36 kilometers per hour, and it increases its speed to 72 kilometers per hour in 1 minute. Find the acceleration of the train. So good, now we have a sum on acceleration, so you can clear your concepts here also on the acceleration topic. But again, do read the topic more in detail so that you understand it clearly. Okay. So let's take a look. So what will this be? We need to find the acceleration of the car. So I know a lot of you are requesting for Hindi videos also. I'll definitely try to make some more videos in Hindi as well, right? So you can check out our Hindi channel, Manocha Academy, Hindi it's called, and I'll try to put more videos there. I know I haven't been able to put more videos recently. So right now I'm focused on the English videos, but I'll start making Hindi videos pretty soon. Okay, so guys, let's take a look at this. The question is, find the acceleration of the train. So acceleration, let's apply the formula that we have learnt. It's rate of change of velocity, right? So V minus U by T. Okay, so V minus U by T is acceleration. So what does this formula mean? So this is basically, this means final velocity minus initial velocity divided by time. Okay, so it's pretty simple, because this is the definition of acceleration, the rate of change of velocity. So what is the change of velocity? Final minus initial. So that is V minus U. Can you see the numerator? And rate means you are dividing by time. So by the definition, the acceleration formula is going to be V minus U by T. Simple. Okay, so now let's go ahead and substitute our numbers here. So again, you can see that we have these different units, you know, we have 36 kilometers per hour, 72 kilometers per hour, then we have 1 minute. So it's again a game of units here. And as we discussed, what do we need to do? So for initial velocity, which is U, 36 kilometers per hour, let's conveniently convert that into SI units. And remember I said the quick technique is the secret trick, multiply by 5 by 18. So what is it going to be? Initial velocity of the train is 10 meters per second, right? Excellent. Okay, and now V is 72 kilometers per hour. So that's going to be 72 into 5 by 18. So same thing, to convert it into meter per second, you multiply by 5 by 18, and that's going to work out to be 20 meters per second. So now we know our final and initial velocity, and the time T is 1 minute. Okay, so 1 minute, guys, we need to convert it again to SI units. So because we are bringing everything into SI unit, 60 seconds. Okay, so this is really important. Try to get it into a standard unit, and here SI unit is the unit that is most widely used. So we convert everything into SI units so that there is no confusion about units, right? You can always solve this sum in kilometers per hour square, but you know, I would recommend to stick to SI units unless given in the question. Okay, so now let's do the simple calculations here. So V minus U by T was our formula. So it's going to be 20 minus 10 divided by 60 seconds, right? So guys, go ahead and calculate that. That's going to be 10 by 60, which is basically, so the acceleration is 1 by 6 meter per second by second, right? So meter per second square, which is, if you do the maths, 0.16666 recurring, right? So that's, if we round it off, 0.17 meter per second square. Okay, so there you can see the correct answer is A. Okay, so please take a look. The right answer here is going to be, can you see that? Just check my calculations in case I've made a mistake here. So please take a look. So it's 10 by 60, 1 by 6, you know, 0.1666. So you need to round it off to 2 decimal places. So 0.166 is going to be 0.17, not 0.16. Always round your answer. Okay, so 0.166, and since the next digit 6 is greater than 5, so it's going to be 0.17. We've given the answer rounded to 2 decimal places. Excellent. So are you clear about this? And see, guys, always you'll get these tricks and these sums with the units. So be sure to write to use the right units, and I showed you this nice trick of converting kilometers per hour quickly to meters per second by multiplying by 5 by 18. So you don't have to do any lengthy calculations. Okay. All right. Are you ready for our next question? A car is moving at 10 meters per second. The driver applies the brakes and the car stops in 5 seconds. Find the acceleration of the car. Okay. So this is again a question on acceleration. So good, we are getting some practice on acceleration sums here. So please try this question. So what does it say? The car is moving at 10 meters per second. okay, and then the driver applies the brakes, okay, and he's going to apply the brakes and the car stops, okay, after 5 seconds. So the car after 5 seconds comes to a stop. So our car stops after 5 seconds, right? And we need to find the acceleration of the car. So again, let's use our formula. So formula of acceleration is V minus U by T. Remember, final velocity minus initial velocity by the time. Okay. So now let's take a look at our numbers here. So you should clearly write down your data. So we are interested in U, V and T. And let's write that from our question. Okay. So what is the initial velocity, guys? U. So what is U going to be here? So good, I see many answers out here. Excellent, everyone's trying. I'm really happy to see that. Amazing. So guys, what do you think is the initial velocity here? U. U means initial velocity. Okay. So the initial velocity, as you can see, is given 10 meter per second. So let's write down that data. And now what is the final velocity going to be? Final velocity means after 5 seconds. So when the car stops. So very good. The final velocity, I see Avinash has the right answer, 0, right? So 0 meter per second. Raman also says 0. Absolutely right. So V is going to be 0 meters per second because that is our final velocity. Why? Because the driver applied the brakes and the car stopped. Okay. And the time is simple. It's given 5 seconds. Okay. So now guys, we just need to substitute the values here in the formula. So it's going to be, so be careful. It's not 10 minus 0. It's 0 minus 10. Okay, final velocity always changes final minus initial, never initial minus final, right? So the change of velocity here is 0 minus 10 and divided by 5 seconds, right? So what do we get here? 0 minus 10 by 5. So that's going to turn out to be minus 2 meter per second square. Why this unit? Because it's the numerator is in meter per second divided by second. So the second doesn't cancel. This second goes below. So the unit is minus 2 meter per second square. Okay, so somebody is asking, I see Red Fire is asking, can acceleration be negative? Yes. So this is also, there's a special name given to that. So when acceleration is negative, like in this case, this is known as retardation. Okay, so acceleration can be negative. So this is called negative acceleration, means retardation. Sometimes it's known as deceleration. Okay, what does this mean? That the car is decreasing in its speed, because normally we think of acceleration means car is accelerating, it's increasing the speed, but a negative value means speed is decreasing. So when you apply the brakes, and note the spelling, it's retardation. Okay, so acceleration value can be positive, that means, or negative. So positive means speed is increasing or velocity is increasing, and here speed is decreasing or velocity is decreasing, means retardation. And yes, one important point here, you can see that there's no mention of direction, right? So it's just been given the car is moving at a speed, or it says just 10 meters per second. So here, when we don't care about the direction, speed and velocity are the same thing. Okay, because here we are assuming it's moving in a straight line, we don't care about our direction here. So when you see these formulas, V minus U means final velocity minus initial velocity, you can substitute the numbers of speed, because direction in these sums is ignored. So speed and velocity for these sums, the value means the same thing. But we know that velocity is a vector, speed is a scalar, but for the value, it's the same thing. Yes, very good. I see Arya says it's called deceleration or retardation. And this is negative acceleration. Excellent. Now let's take a look at the next question. Let's say you drop a ball from a tower. Okay, so a ball is dropped from a tower. What will be the velocity of the ball after 2 seconds? Okay, so let's say this is the ball here, right? And it's dropped from a tower. So the ball is falling down towards the ground, right? And we want to find its velocity, right? So velocity, again here, as I mentioned, velocity means speed, because direction is not important. As you can see in the answers, there's no mention of direction. Direction is downwards. So speed or velocity can be used interchangeably here, right? So we are interested in the speed, or we say velocity of the ball after 2 seconds. So let's say the time starts here. So time here is 0 seconds when he drops the ball. Let's say after 1 second and 2 seconds, the ball is somewhere here. So we need to find the velocity of the ball. Okay, so Great. I see a lot of you trying the answers, but again, I'm not seeing units. So guys, it's okay if in the chat you're just writing the number, but don't forget the units, okay, in your test. So how do we do this question? So one way is to use our acceleration formula that we learned, because one thing, when a ball falls, is it accelerating? Yes, because the earth is applying a force on the ball, right? So we know that the earth applies a force on this ball. So earth is applying the force of gravity. So gravity is the force here, and so it's causing an acceleration due to gravity. It's pulling the ball down. So the force, you know, causes an acceleration, and this is known as acceleration due to gravity. Okay, so the ball is definitely accelerating, and we want to find the velocity of the ball. So guys, do you know what is the average value of acceleration due to gravity on the earth? So what is the average value of acceleration due to gravity on the earth? What is it? Very good. It's 9.8 meters per second square. That's the average value, right? So, or approximately 10 meters per second square. So the average value is normally taken as 9.8 meters per second square. This we denoted by G, or we can say A. So now if we apply the formula, A equals V minus U by T, right? So what is the value of acceleration due to gravity here? We are going to use the number 9.8, or we are interested in calculating V. So let's rearrange this and write this as V equals, so T is going to go on top and U will go on that side. So it's U plus AT. So I've just rearranged the acceleration formula so that V becomes on the left hand side, because look here, we need to find V, right? So what is it going to be? Initial velocity plus A into T. Now this is the interesting question. What is the initial velocity here? So when you drop the ball, what is the initial velocity of the ball? So guys, what do you think? So when you drop something, right, like the ball here. So if you drop something, what is the initial velocity of the ball? Very good. I see the right answer, 0. So because the ball has just started moving. So just at the instant of 0, the ball's initial velocity is going to be 0 meter per second. So this is going to be 0 meter per second, and let's substitute it here in our equation. And the acceleration we are given is 9.8 meters per second square, right? And the time is given as 2 seconds. Okay, so we are using this formula. We rearranged it and we are calculating V. So we have 0 plus 9.8 into 2. So that's going to give us 19.6, and velocity or speed, we know the unit is meter per second. So the right answer is 19.6 meter per second. Excellent. I see a lot of you got that answer. Superb. So that is the right answer here. If you had used the approximate value of acceleration due to gravity as 10 meter per second square, so let's say if you had used the approximation, then you would have got 20 meter per second, because it's 10 into 2. But since that's not in our options, we need to use the velocity, the value of 9.8, the more accurate value here. And I'm seeing a lot of you are saying the right thing, that this equation, if you recognize, this is actually the first equation of motion, right? So I have a video on that also, on equations of motion. You can watch that. So V equal to U plus AT is our first equation of motion, and we have we can easily derive it from this acceleration formula. So there's nothing great about it. You start with the acceleration formula, A equal to V minus U by T. So you take T on this side here, right? So it becomes AT equal to V minus U, and you rearrange it and get V equal to U plus AT. So either you can directly use the first equation, or you can start with the acceleration formula like we did here and solve this sum, right? So this is how you do this question, and the right answer here is 19.6 meters per second. Excellent. And now here's another interesting question for you. Now if you drop a ball on the surface of the moon, so imagine you're on the moon now and you drop this ball on the surface of the moon, okay? And so this ball is falling towards the surface of the moon. The question is, what will be the acceleration of the ball? Is it going to be A, 0 meters per second square, or B, 1.6 meters per second square, or C, 9.8 meters per second square, or D, 10 meters per second square? So guys, what do you think is the right answer? And I want you to write the answer in the comments below. So I'm not going to give the answer right now. in this live session, I want you to try this question yourself, or you can research about it, that what is going to be the acceleration of the ball when it falls towards the moon. So let's say you've gone on the moon and you're dropping the ball, and so do you think the ball is going to be pulled by the moon or not, and what will be its acceleration? And do let me know your answers by putting it in the comments below. I look forward to reading your answers, and I'll definitely reply to your comments. Okay, so I want all of you to try this question, and guys, if you haven't hit the like button for this video, hit it right now and do share it to your friends. I'm trying to take live classes every day at 8 p.m. so be sure to attend them. They're going to be on physics, chemistry and maths topics, and I'm sure you'll find them useful and interesting. So I see a lot of answers here, but I'm not going to tell you which one is right. So guys, please try it yourself and write your answer. And as I said, do check out our website, manochaacademy.com. We have these physics courses for CBSE Class 10, Class 9 and ICSE Class 9. And we'll also be very soon launching the chemistry and maths courses. So guys, do check it out and share it with your friends. And it was an awesome session. I really enjoyed it because all of you were very interactive, answering the questions. I absolutely love that thing that everyone was trying it here. So great. Yes, I'll definitely be making class 9 chemistry videos and for class 10 also. So do check out our website and this YouTube channel. Thanks a lot, guys. Thanks a lot for your love and support. And please share it out with your friends, and don't forget to hit the like button and the subscribe button for our channel, and also hit the notification bell so that you don't miss any of these live classes or the new videos that we upload. So do hit the subscribe and notification bell right now and hit the like button for these videos. Awesome, guys. Oh, so what is the class timing for these live classes? As you can see, I've been taking them at 8 p.m. every day. So I hope that's a good time for you guys. 8 p.m. will be the daily live classes, right? And during this time of lockdown, I hope it's helping all of you. So do attend it and do share it out with your friends so that we can have more people be here on these live classes and benefit from it. So what will I be taking tomorrow? So today was physics, so tomorrow it will probably be chemistry or mathematics. So I'll also decide and let you know, but I do send out the notification 2 to 3 hours or at least 2 hours in advance. So please check around 6 p.m. I think you'll get to know by then the topic, and do attend the class which starts at 8 p.m. Okay, great. Oh, and what's my name? My name's Sandeep Manocha, and that's why our channel is called Manocha Academy, and that's Manocha Academy website, manochaacademy.com we have. So here's Sandeep Manocha signing off. Have a great day, guys. Take care, and bye-bye. And as I told you, tomorrow's topic is either going to be chemistry or maths. So do check it out and share it to your friends. All right, take care. Bye, everyone.